I'm Donna Malayeri. I'm a product manager on the serverless team. I work on Knative Eventing and App Engine Flex. So why don't you take turns introducing yourselves?
Sure, is this on? Great. So I'm Morgan Hallmon. I'm also a product manager on the serverless team. I work on our event-driven infrastructure and products. So when you've used a cloud function and you've triggered it off of a GCS bucket, a real-time database transaction, or a Firestore collection change, that's the work I've been doing.
Hi, my name is Karolina Netolická. I am a product manager for serverless networking. So I manage the networking features for App Engine, Cloud Functions, and Cloud Run.
My name is Abd-El-Malek. I'm a software engineer working on serverless infrastructure. So it's the same infrastructure behind App Engine Standard, Cloud Run, and Google Cloud Functions.
Hi, my name is Matt Soldo. I am the product manager for App Engine Standard, and I am a mediocre Ruby developer.
All right, so one of the things we've realized this week is that serverless means different things to different people. In fact, some people have been saying, you've launched a new product, that's not serverless. So yes, that's totally serverless. So we're not going to answer and debate what serverless is and isn't, but instead, what I'm going to do is invite each panelist to talk about why they are personally excited about serverless. And I'll go last, so why don't you start, Morgan? Why are you excited about serverless?
Sure. So I'm super excited about serverless. I mean, obviously I'm a serverless product manager, so I'm somewhat biased. But that dev keynote yesterday was called "Get to the Fun Part," right? And I think that's what serverless represents for a lot of developers. It is the business logic, the business value, versus all the mundane, yet very, very important operational things like patching OSs and configuring web servers and horizontal scaling. We just abstract all that away for you. And we see examples of this. We've got customers on Cloud Functions, on Google App Engine, that are serving millions of end users with ridiculously small operations teams of like 1 to 2 people. And so that just shows you how productive, how lean a developer team can be when it doesn't have to think about infrastructure. And so I'm super excited about broadening that. So products like Cloud Run that lets you bring many, many more things to serverless so that all developers can reap those benefits of serverless architecture, serverless architecture.
So one thing that excites me about serverless is you only pay for what you use. And so I'll tell you a story. I joined the App Engine team about 3 years ago. And so I've worked on a number of features for App Engine. And typically when we're close to releasing, I create a personal test account with my personal email because I just want to make sure to use it like a regular user. And I test the feature, and then we ship it. And so recently I started working on VPC connectivity. And so I created a personal test project, and I created a couple VMs so that I have something to connect to, and I send out the link to a couple of other people. And at the end of the month, I got a bill, and it was $250 to my personal account. And I said, what is this? I've never gotten a bill in 3 years that I've worked on App Engine for testing these things. And then I realized, oh, serverless is great.
What I'm really excited about is just how easy it is to build applications. And as serverless got more powerful over the years, right? We have a bunch of limitations, especially in the earlier versions of App Engines. In say Cloud Functions, we had a concurrency limit, and there were a fixed number of languages that were expanding, but there's still some kind of limitations there. But we're now getting into like much lower limitations in Cloud Run, and that just makes it there's a wider room of applications you can develop, while still getting the benefits that my colleagues earlier mentioned in terms of not having to think at all about any operations aspect.
Yeah, so it's almost become trite, but it really is the case that every business is becoming a software company, and I really think for the majority of businesses, serverless is the right solution for them. Unless you are innovating at a very low level of compute, why bother dealing with servers or OSs? I was talking to a customer yesterday who's on App Engine, and they are a book self-publishing business. They let authors self-publish their books, and they have a 3-person development team, very, very small, and they're able to do that because of serverless and the productivity that it provides them. And enabling businesses like that really is what gets me excited and makes me psyched to get out of bed today and show up to work and make it easier for those kinds of companies.
Yeah, for me, it's something similar. I've worked in the serverless space for over 3 years, not all of it at Google. And I've worked in programming languages and developer tools my entire career. And the big aha moment for me about why serverless was great is when I had a lot of client developers come up to me and say, I have never built an application that connects to something before, not end to end. I was always writing the client, someone else was writing the service, and I have never done anything on the server before. And I walked up and I used a functions product, and now I'm productive. Now I can build an end-to-end application. I can work on the parts I know, which is the client, and the server stuff is so simple that I can manage that all myself. So it really eases the burden of having to do something on the server. It makes it a lot more accessible for more developers, and even for developers who could build a complex server application. You don't have to. You get to focus on the fun stuff, as they were saying in the developer keynote yesterday. All right, so I'm going to open up. I'm going to ask some panel questions, and then we'll get to Q&A. So we're going to do about maybe 15 minutes of pre-canned questions, and then we'll take questions from you. So Morgan, this week we launched Cloud Run. Can you tell us what it is and how is it different from Cloud Functions?
Sure. So Cloud Run, you've probably heard about it. It was in, I think, two or three keynotes, actually.
Actually, show of hands, who has seen Cloud Run demos this week?
Oh, that's
Awesome.
Great. For those of you who haven't, watch Michael's talk. Very impressive. So Cloud Run, so what it is a product that allows you to run HTTP-driven containers in a serverless fashion. So what does that mean? It means that if you can build a container, if it can be hit via HTTP, you can run it without worrying about any of the infrastructure. So all the provisioning of the infrastructure, all the configuration, all the scaling, Google worries about that. You worry about your code and your container. And so that probably seems very interesting, but why is it important? It's important because historically, one of the biggest barriers to adoption of serverless for some of our other products like Google App Engine or Cloud Functions has been that customers haven't had as much control as they needed over the runtime. Now, let's be honest, App Engine and Functions support a ton of different languages and runtimes, so many things fit very neatly into the serverless box. But if your app didn't, and the worst case is when you had one tiny little thing, like I need one library that I just can't use with App Engine or with Functions, then you were completely shut out of the serverless vision. And so the great thing about Cloud Run is that because you can bring a container, you can basically run anything, right? So that key barrier has now been broken down, and we've broadened the set of workloads that are addressable by serverless, which really excites me. Cloud Functions is a much more curated and opinionated product in that we, Google, provide you with the runtime. Now, again, we support many runtimes, many languages. We've got Java, Go, Python, Node. So many developers can use functions. It's not a huge limitation. Obviously, as I said before, Cloud Run lifts this limitation. But if your thing does fit, if your workload does fit into a Cloud Functions runtime, then it's a much more productive, much faster way of developing because you just worry about what's between those two curly braces. You just worry about the business logic, the application logic, and you leave everything else to Google. So I'd say that's the big difference between Cloud Run and Cloud Functions. I do want to talk about the Functions Framework, which we also announced a couple days ago. So the Functions Framework is kind of like the best of both worlds in a sense, in that it allows you to write function code. So again, just worrying about what's between those two curly braces, not worrying about any of the rest, but however, run it anywhere and be very portable. In that the Functions Framework is essentially a library or a set of files that you would put in your directory in what you're developing, and it takes care of all the configuration that's needed to do a build, so to build that container that can then run on Cloud Run, can then run on Cloud Run on GKE, can then run anywhere that Knative, which is the open API specification for Cloud Run, runs. So you could run it on any Kubernetes cluster running Knative. So it could be on-prem, it could be on AWS, it could be on Azure, wherever you want to run that. So it's kind of the best of both worlds in that you just focus on the application logic, yet you get the portability and the flexibility of having a container that runs anywhere.
Great. All right, so Morgan, you mentioned that Michael had a great talk about this. He did a scale demo that everybody is talking about on Twitter, and where you scaled up to, I think it was, how many nodes?
10,000.
10,000 nodes in less than 10 seconds. So why don't you talk about how we did this scaling and what kind of scale we're seeing here in Cloud Run that is really unparalleled in this industry?
Sure. So with serverless workloads, they tend to be bursty. And we wanted customers to be able to use our serverless products and not have to worry about, like, do I need to pre-spin kind of instances? Do I need to send some artificial workload to kind of get more instances ready for any kind of event that I know is coming up? And so we wanted to really kind of push the boundaries on rapid, fast scaling of instances based on customer workloads so that customers don't have to think about any capacity or instances, pre-warming, etc. And the way we've kind of pushed the boundary in Cloud Run, and I just want to note that the same infrastructure powers all of our 3 serverless products, and so we're kind of enabling it first in Cloud Run, but we'll get it soon in Cloud Functions, and App Engine's billing model makes this a bit difficult to introduce there, but we're going to have this in Cloud Functions as well. But to Donna's question, so how do we scale to 10,000 instances in a matter of 5-10 seconds? The way we do this is when a request comes to our networking front ends, the front ends go to a small set of application servers to see if there's an available instance that can handle the request, or if these application servers can start a new instance to handle the request. Now, if the application servers are busy because they already have too many instances, the networking front ends will try an ever-expanding group of application servers to start an instance in, or to look for an instance that has available capacity. And kind of the key thing that makes this work is that all the different networking front ends, and we have thousands of them in each region, in a decentralized manner use consistent hashing so that they're going to the same set of application servers for a particular service and revision as the other networking front ends without any communication. So there's no centralized scheduling or centralized load balancer that can either be a bottleneck for scaling or an availability bottleneck. And so as we try bigger and bigger sets of application servers to start instances, and that kind of simultaneously lets us scale quickly, but also avoid too many cold starts. Because you could, one way to do rapid scaling is to just randomly go to any application server. And if you have thousands of them, you're going to incur a lot of cold starts more than you need. And so as we kind of go in ever-expanding groups, and as long as the application servers can respond quickly and say, hey, I'm busy, go to another application server, then we can rapidly scale in a matter of seconds to thousands of instances.
Right, and the reason this matters, so cold start is the time it takes when there's nothing running to actually getting a response, right? And so you want customers to get a response right away, so you want low cold start. And before serverless and before this fast scale out, what customers would do, and other cloud vendors I worked in, they would pre-provision. They're like, oh, we have a big sale coming up, or it's Black Friday. Let's allocate. I'm seeing some nods in the audience. Let's allocate thousands of VMs in advance so that we're ready. And what happens is you have to do all this capacity planning in advance. You pay for capacity you're not using. If you're wrong, if you've under-provisioned, now you're really stuck because you have to wait, minutes for new capacity to start up. So that's why this scale out is so valuable, and it's one of those things that makes serverless actually useful in practice when you have a lot of load coming to your service. So I recommend watching the video for Michael's talk. It's really fascinating. So now we launched a new product, and of course when a new product launches, everyone asks, does this mean you're not working on the old products anymore? And the answer is no, we are still working on the old products. And if you look at our blog post, you can see we have a lot of new improvements in Cloud Functions as well as App Engine. Matt is the product manager for App Engine. So why don't you tell us about what we've released for App Engine this week?
Yeah, that's right. So we got a whole paragraph in the blog post about our serverless offerings, but really development is very active on App Engine. We released a lot of really fun new things. So some of you may see, who is an App Engine user, like is running something on App Engine? Good, like About a quarter of the audience. Great. So last year we released second generation runtimes for App Engine. These are built on the same infrastructure that Cloud Run is built on. Under the covers, they run actually a Docker container, but you're not exposed to that. And these unshackled App Engine from the previous constraints, where you can run any language library. You have open network access, which, believe it or not, you did not have in the first generation of App Engine. And so basically, you can run any code. You don't have to write your code specifically for App Engine, which you did in the past. And so on Tuesday, we announced several new runtimes. We have PHP 7.2 in GA, Python 3.7 in GA, Node 10, and we also have Ruby in alpha and Java 11 in alpha. It didn't make the blog post, but right about now or shortly, Go 112 is also going into beta. So we have a slew of new languages. It's really awesome. But almost more importantly, and Karolina's going to talk about more of this, is VPC Connect for App Engine, where you can have an App Engine app connect to services that are running in your Google Cloud VPC. So yeah, that's right.
Yeah.
That's right. So the biggest request we had on the second generation runtimes was the ability to access a cache, because the second gen runtimes do not use the legacy App Engine services like the Memcache service that was bundled with App Engine originally. So now it's really easy. You spin up a VPC connector, you spin up your Redis and Cloud Memory Store, and you've got an awesome cache. It's plain vanilla Redis. It works great. One final thing that is really exciting that also didn't make the blog post, but many of you will be hearing about this for the first time, is this quarter we're going to be doubling the memory on all second generation runtimes at the same price. So whatever the memory is on the instance now, you'll be getting double that, no change in price. So really exciting. It's a great product. We've designed the second generation runtimes to be future compatible with Cloud Run. So if you are shy about using a beta product, no problem, develop on App Engine, and then it's going to be an incredibly simple, like almost a one-button migration if you ever want to use Cloud Run in the future.
Right. Yeah, everyone got really excited about VPC connectors. This is a really off-request feature. We finally made it happen. We can, if you want to applaud VPC connectors, go ahead now. And Karolina is the one who made this happen. So why don't you tell us about the feature we launched and why it's important beyond the case that Matt just talked about?
Right. So if you use App Engine, chances are, like, most customers use more than one of our cloud products, right? So there are many use cases where you actually need to use, you want to use App Engine or Cloud Functions, so serverless front end, basically. But it needs to talk to something that's running in your VPC. Perhaps you have a GCE VM that's running some off-the-shelf software that isn't a good match for serverless, and you need to call that from App Engine. Or perhaps you wrote some services in GKE because you needed to use GPUs, and you need to access that from Cloud Functions. Or perhaps you have an on-premise database that's connected to your VPC network via Cloud VPN, and you want to access that from your App Engine app as your storage layer. So for all these use cases, in the past, the options were limited. You had to basically give the resource in your VPC network a public IP address, and that's how you connected to it. It's as if it was running, like there was no advantage to the fact that they were both running in Google Cloud. So what we have launched now is we have a feature called Serverless VPC Access, and it's now in beta. The way you use this is you create a VPC connector in the same region as your app and in the same VPC as the things you're trying to access. And then you redeploy your app or function. So just a new version, specifying the name of the connector. And from then on, if in your code you make a request to a private IP, that request is going to go to the VPC connector, and from there travel through the VPC according to however the VPC network is already set up. So it's going to respect all of your firewall rules. It's going to work with Cloud VPN. And it's going to reach its destination. So now you can use Cloud Memory Store, which previously you actually couldn't use because Cloud Memory Store doesn't let you have public IPs. And you can use Cloud Functions and App Engine with compute engine, GKE, without having to make those resources public. So it improves your security. It also lowers latency a little bit. So that.
Yeah,
It's super cool.
It's a great feature. Try it out. We're all really, really excited about it. Unblocks lots of scenarios. There's two versions of Cloud Run. There's a Cloud Run hosted, fully managed version, and there's a Cloud Run on GKE. It's basically the same developer experience on either, but you can, if you run on the GKE version, you're managing the Kubernetes cluster yourself. If you're running on hosted Cloud Run, we manage things for you. So, Michael, can you tell us, what do we manage on behalf of customers? What worry do we take away from customers?
Sure. JKE, we are managing some of the operations for you, but you still have to have a JKE cluster. And so with the hosted Cloud Run, you don't have to have a JKE cluster at all. Or if you have a JKE cluster for other use cases, but you don't want to kind of mix those workloads, then that remains on our internal hosted platform. We can scale up faster on our internal version of Cloud Run. And so the 0 to 10K kind of scaling demo that Donna mentioned earlier, that is, we do not scale that fast yet on JKE, so you wouldn't get that scaling performance. So that's kind of another thing that is an advantage of using the hosted version. Of course, we are working on making JKE scalability faster, both for this use case, for Cloud Run on JKE, as well as other customer use cases on JKE. But the technology that's underlying Cloud Run hosted has been easier to make it scale up faster. There's no exposed kind of versions you have to think about in terms of node versions or JKE versions, master or node versions. And so in the Cloud Run hosted, there really is no operational aspect that you have to think about. All of that stuff is behind it, runs on our internal kind of data, the data centers that are for internally in Google. So all of the kind of security, operating system, image stuff, all of that is hidden from you, and we take care of doing that. If we have to update our own servers, that is done transparently to you. The request routing will find kind of an available version. If there's any server failures, node failures, all of that is hidden from you.
All right, thank you very much. Thank you for all your questions.